All right, Algebra 2, we're going to continue on with logarithms and exponents, and we're going to be doing logarithmic equations today. It's not as bad. It just requires everything we've learned so far. So I'm going to go ahead and go through all these notes relatively quickly so that if you miss anything in the live lecture, you can have this. All right, we're going to start by looking at the examples 1 and 2. Before I get into that, this right here is just letting you know a couple of things that you can't have with logarithms. So, for instance, you'll never have a log base 1. You'll never have a log base 1. That's just not going to happen. It's because it's like saying what is 1 to the power of 10? 1 to the power of 10 is just 1. So anytime you have that, it's going to equal that. The other thing it's saying is we don't have negative numbers. You'll never have a log of negative 10. You'll never have a negative here. So it has to be bigger than 1, or greater than 0, and cannot be equal to 1. So just know that. And now let's talk about these actual problems. How to write each of these in logarithmic form. You ready? It goes like this. When you go from exponent to base to then what it actually equals, it writes like this. Log, the base goes here. What it turns into after you apply the exponent goes here. And then the exponent goes here. That's number 1. Let's do this one again here pretty quickly. The base is 7. The exponent is 2. And then when we raise it there, that's what we get. So that's basically how you do that. That's just a review from previous stuff. I'm going to go ahead and do 3 and 4 as well so you can see how this works. When there's no base, remember that number is 10. So I can rewrite this as 10 squared is equal to 100. Hopefully you can see that. And then on number 4, I'm going to do the same thing. I'm going to go backwards now. My base is 2. My exponent is 4. And then I'm going to equal it to 16, which works out to be true. 2 to the 4th is 16. Now, let's go ahead and get to evaluate each expression. Are you ready for this? When it says evaluate each expression and you have no idea how to do it in your head, you can, of course, technically put this into the calculator, and it will tell you what answer it is. But there's another way you can do it where you basically add your own variable. You can say, this is supposed to come out to some exponent named x. So watch how I rewrite this. Now that I've added that x, I can rewrite it as 2 to the power of x is equal to 8. And then throwing back to what we did a couple weeks ago, like a week or two ago, you can change the base here for 8. So I can say 2 to the x is equal to, I'm going to change this base from 8, and I'm going to express 8 as 2 to the 3rd. And for those who don't know, 2 to the 3rd is 8. So we've done this quite a few times. So what ends up happening is, remember, when we have the same base, we can basically just look at the exponents now. So when it's all said and done, I end up with x equals 3. And if you were to type this in the calculator, that's exactly what you would get. Let's check out this one over here. I'm going to go ahead and add my x right here. And I'm going to rewrite this. 7 to the x equals 1 over 49. This looks crazy, but we're going to do change of base. Remember, I'm going to get this 49 to go up on top. And the way we do that is we change the exponent sign. So remember, each number has a 1 up in there. So watch this next little line. I'm going to move this 49 up, and when I do, I have to change my exponent to -1. Then the next thing I'm going to do is I'm going to basically change this 49, and I'm going to express it as 7 squared. Hopefully this comes back to you. We've already done this. We did this a little bit. 7 squared, and then I have that -1 still that goes right there. And then remember the rule of exponents. An exponent on top of an exponent means you're going to multiply. So here's my ABC, and then here's my step D. You're going to multiply, so I end up with 7x equals, or 7 to the x equals 2 times -1 is -2. So I end up with x equals -2 for my answer here. Going on to the next stuff, this is just a refresher. Keep in mind it's just rules of exponents and changing the numbers into perfect squares or perfect cubes or something. Going to the next one. Solve each equation by changing to exponential form. So I'm going to go ahead and follow how I got this. The base is 9. The exponent is 3. And then it's going to be equal to x. I have to use Desmos for this. I don't know what 9 to the 3rd is. So I'm going to go over here to my Desmos and type in my 9 to the 3rd, which gives me 729. So when it's all said and done, I end up with 729 equals x. Now I'm going to go ahead and do this one. This is kind of interesting. Check out number 8. Of course, we get this more complicated. Mister, there's a 2x over here. What do I do with this? Pay attention. This is in the exponent spot, so I'm going to raise this up to be 3 to the 2x equals 81. Now check what I have to do with this 81. I need to change it into base 3. So when I do that, I'm going to change it into 3 to the 4ths. I end up with 3 to the 4ths. And if you typed in 3 to the 4ths, which I'll show you on Desmos, if you typed in 3 to the 4ths on Desmos, you would get 81. That's where I'm getting that number. So now guess what we have? We have the same base on both sides, and now we have exponents. So I can just take those exponents and set them equal to each other. 2x equals 4. This reads as 2 times x, so I'm going to divide this out, and I end up with x equals 2 for my full answer. That's basically how these go. And if you're panicking about these in class, yeah, I'm going to be walking around today. There's plenty of, you'll have help today. The base, log base 10. If there's no base there, that's the base, 10. Watch how I rewrite this. I get 10 to the 3rd equals 5x minus 10. You see how that 5x minus 10 is in that position? See how it's in that one spot? The rules of rearranging stay the same. 10 to the 3rd is 1,000, equaling to 5x minus 10. I'm going to add the 10 on both sides. That looks like a 16. Welcome to it. Add the 10 to both sides, and I get 1,010 equals 5 times x. And then I divide the 5 out on both sides. Normal equation stuff at this point. And what do I get? 202. X is equal to 202. I believe that's accurate. Let's make sure before I say so. 1,010 divided by 5. 202. All right. That's basically on that. I'm going to go ahead and solve number 10. It's not that big of a deal. Here we go. Rearrange this as y to the 1/3 is equal to 4. So this looks kind of weird and bizarre on how to solve these problems, but it's not that bad. Hold on one second. There's a rule y'all might have forgotten, but in order to clear exponents like this, do you remember how to clear exponents? What you can do is you can flip the exponent upside down and raise it on top of itself. So you end up with 1/3 times 3 to the 1, which would cancel out. But if you do that, you have to do it on both sides. Remember this. So you end up with y to the 1/3 times 3 over 1 cancels out, and it gives you just y. And then when you get y equals 4 to the 3 over 1, which is just 3, which is just 4 to the 3rd, which is just 64. So you end up total with y equals 64. So that's a skill you'll have to remember how to do as well today, flipping the exponent, which most of y'all will remember after seeing it one time. I'm going to go ahead and finish this one. This is cool. So you can see that this has more than just a log here. Whenever this is the case, excuse me, whenever this is the case, you want to get everything over on one side and the log on the other side. So I'm going to subtract my 22 first, and I'm going to bring it over, and then I have 2 log base 3x equals 8. You see this 2 times log right here? You want to divide this 2 out. It'll be so much easier if you divide the 2 out on both sides. So you end up with log base 3x equals 4, because 8 divided by 2 is 4. And if you're wondering what canceled out, this is the 2 that canceled out with each other. And then you're left with this. Then you can go ahead and rewrite your log as 3 to the 4th equals x. And 3 to the 4th is 81 equal to x, and that's our full answer. Going to go over to this one, check this one out. I'm going to subtract 10 first on both sides. So I end up with log 2x equals 3. I'm going to rewrite this to get rid of the logs, and I'm going to have 2 to the 3rd equals x, which then works out to x equals 8. So that's the quick little rundown of these problems if you miss any in class today.